We're going to look at some symbols, notation, and terminology used with math. First, we have the equal symbol. Next, we have is not equal to, which is the equals with a slash. Then we have greater than, less than, greater than or equal to with the equals line underneath, and less than or equal to. Next, we want to look at some notation for multiplication. Our x is gone because we use x as a variable, so we don't want to use it to mean multiplication. We can use a raised dot, which is about halfway up. So like 3 times 2. You don't want it down at the bottom so that it would be confused with a decimal. We can use parentheses side by side. So like 3 times 2 with nothing in between. We can use a number right beside a parentheses. Nothing in between. We can use a number right beside a variable with nothing in between to mean multiplication. And we can use variables side by side to mean multiplication. Also later we will have brackets. Brackets do the same job as parentheses, so you will be able to have 3 right beside a bracket to mean multiplication. Some terminology and notation. First, we have absolute value of a number is the distance from 0. The notation for absolute value is long straight marks longer than the number, and the number will be on the inside. So this notation is asking you how far is 2 away from 0. And you could answer, if you looked at the number line, 2 spaces. We can also do absolute value of a negative number. This is asking how far is negative 2 away from 0. It still just wants to know distance, not direction. And this one is also 2 spaces. So the long straight marks mean absolute value. They have a special meaning. Opposites are numbers that are the same distance from 0 on opposite sides. For example, 5 and -5 are opposites. We can also read the negative sign itself as the opposite of. If we just have this, we would say that as -2. But we would be allowed to read it as the opposite of 2. The time when it's helpful to read it as opposite is if you have extra notation. So, for example, if we have this, right, say the opposite of whatever's inside. Opposite of a -2 would give you a +2. And so it would help you to clean it up by saying opposite of for the outside symbol. So with only one, just say negative. But if you have extra notation, you can read the outside one as opposite of. Notice here, the parentheses does not have any special meaning here. It's only holding the sign on the inside. Next, we want to look at exponential notation. It has a number down lower, which is called the base, and a small number up above, which is called the exponent or power. And this notation has a special meaning. It means for you to take the base times itself the exponent number of times. So this says take 2 copies of the 5. And then you could multiply them out. So this is factored form or expanded form. And to work them out, we evaluate it. So we multiply them together. Let's go over how to read these. So if we have something to the second power, we can say 5 squared. Or we can say 5 to the second power. If we have 3 for an exponent, we can say 5 cubed. or 5 to the third power. After 3, we'll always just say to the power. So if we have 4 for an exponent, we would say 5 to the fourth power. And all of these would mean to take the exponent number of copies of the base. The exponent that we don't usually see is a 1. Let's look at it for just a minute and see what we would do if we had a 1 there. We would read it as 5 to the first power. But if we try to simplify it, it says 1 copy of the base. 1 copy of the base is just a plain old 5. And so that's why we don't see the 1 written there. So no exponent at all would be a 1, or we could write the 1 and clean it up, but it would give you just 5.